Hello everyone. In this second video of backpropagation, we will see how to find out gradients which are useful to find out the updates or to calculate the updates for weights and biases. So this is computation graph for two-layer neural network. So this is your first layer and this is the second layer. Now what we want to learn the efficient value of W1, B1, W2 and B2 and how we can learn those weights by training our network with the given example. So to update this W and B means weights and bias at layer 1 and at layer 1, we need to find out what is the contribution of these weights and bias to ultimate prediction, or more specific to this loss, right? So we want to minimize this loss. So whenever there is a new feature or example, we can predict the output very close to the original one. So that's why we find out what is the impact of this activation, this Z, this bias, weights, and this weights bias to the loss function, right? And this derivative indicates that thing. So ultimately, we want to find out dB2, dB2, dW2, dW1, and dB1, right? In the previous video, we have seen the gradient descent update. So what we do in that, if I write for W1, then your W1 that is equivalent to W1. This is the old W1 minus alpha time dW1, right? So this way we update the weights and same way we update for B1, same way for dB for W2 and for B2, right? So let's see how to find out this derivative, right? How we'll calculate this value. So here this dA2, dZ2, dW2, dB2, these all are derivative based on that particular variable. If I talk about this dB2, then this is equivalent to dL upon dB2, means derivative of your loss based on your bias, which is going to layer 2, right? Let's see how to find out these derivatives. Okay, so this is your loss function L minus y log a2 minus 1 minus y log 1 minus a2. What is a2? A2 is your prediction, right? So after you calculate Z2, you perform some activation on that Z2 and that is your A2, and A2 is your Y head. So instead of A2 you can also write Y head, but as we are using that variable, it's better to write that A2, right? So first term means first thing we will find out that what is the impact of this A2 on the output or prediction. First we will find out dl dl upon da2, right? So we'll find out dl upon da2. So this log function, derivative of this log function, with respect to a2. What is that? So if we find out the derivative, then this is the constant term. So minus y and log a2. So derivative of log x, that is 1 upon x. Based on that, derivative of log a2, that will be a 1 upon a2. So this is first term. Now for second term, minus as it is 1 minus y, that is constant term. So 1 minus y. Now derivative of log 1 minus a2. So as we have seen in the derivative rules, the derivative of log 1 minus x, that is equivalent to 1 upon x minus 1. But if I want to write in reverse form, instead of 1 upon x minus 1, if I want to write 1 upon 1 minus x, then I need to include minus sign, right? So same way, the derivative log 1 minus a2, that will be 1 upon a2 minus 1. But I want to write like this, 1 minus a2. So there will be a negative sign, and this negative and negative, that will become plus. So this is the first term, dl upon dA2. This is dA2 will indicate like this, right? Okay. Now after this, how we calculate this A2 based on your Z2. So what is the impact of this Z2 on the loss? That we'll calculate, because ultimately we want to find out this dW2 and dB2. So for that we need to find out this Z2, right? Let's see. So dl upon dz2, which is your dz2. For simplicity we write dz2. So based on chain rule, we can write like this, dl upon dA2 into dA2 upon dz2, right? So this is based on chain rule. So if you can see, the ultimate is last thing, dl upon dz2. So this is intermediate term. Now we right now calculated this thing, dl upon dA2, right? And that is minus y upon a2 1 minus y upon 1 minus a2, right? So we have calculated that dA2, and this is dA2 upon dz2. So you can see here, this is derivative of your activation function, and here the activation function that we are using, that is sigmoid activation function, right? So derivative of sigmoid for activation function, if you remember, if f of x or take g is your activation function, then g dash is equal to g 1 minus g. This is derivative of your activation function, and we have seen the derivation of that in the previous videos, right? So here the activation function is a2. So if I need to write in that form, then derivative will be a2 1 minus a2. So this is derivative of your activation function with respect to z2, right? Now if you simplify this thing, then this will become minus y 1 minus a2 plus 1 minus y into a2, and in denominator a2 1 minus a2, and here your derivative of activation function a2 1 minus a2, right? So we can cancel this thing, a2 and 1 minus a2, right? Now if you simplify this thing, then what you will get? You will get a2 minus your y minus y. Y is your original value. Y is your original value. So in this loss, your y is original and this a2 is, that is prediction, right? So a2 minus y. So your dl upon dz2, or you can write like dz2, that is a2 minus y, a2 minus y. So if you know the value of a2, just subtract from the original, that is your dz2, right? Okay. Then next, now your z2, that depends on w2 activation and your bias. So we'll see first the derivative of z2 with respect to w2, right? So dl upon dw2 means what is the impact of this weight w2 to this loss function L. So again with the chain rule you can write like this, dl upon dz2 and dz2 upon dw2, right? So this thing we know, dl upon dz2, which is equivalent to a2 minus y, right? And dz2 with respect to your variable w2, that will be d upon dw2. What is z2? See this, z2 is w2 a1 plus b2, right? Now for this term, this will be as it is, a2 minus y. For this term, this is derivative of sum. So w2 a1, so a1, that will be constant, right? So a1, that will be constant, dw2 upon dw2. So dx upon dx, that will be 1 plus, this is the constant term. Derivative of constant term is 0. So plus 0. So we can directly write like this, right? This is a1. Let me write it properly. Is a1, right? Okay. So this is a2 minus y into a1. What is this a2 minus y? That is your dz2, right? So we have already calculated dz2. So no need to again calculate like this a2 minus y. So we have value of dz2. You can directly put it over here dz2 into your a1, right? So this way we can calculate dl upon dw2. Now same way dl upon db2 means your bias term for that. So what will write? Chain rule again. dl upon dz2 and here dz2 upon db2, right? So this term dl upon dz2 you can write like this dz2, right? So we'll write like this dz2. Now this dz2 upon db2. So you can see here, so z2 that is as it is w2 a1 plus b2 upon, instead of this w2 now we have b2. So if you perform derivation, so for variable b2 this term is constant. So derivative of this constant term that will be 0 plus derivative of that variable means dx upon dx. So in this case dw2 upon dw2 that will be 1. So multiply by 1 that will give you dz2 only. So for db2, right, I'm interchangeably using dl dw2 as dw2, similar way dl upon dw2 as dw2, right, same way for others as well. So dw2 that is your dz2. So you can directly write like this, right? Now next, your dl upon da1, right? So let me drop this. So right now we have calculated da2, then dz2, then we have seen dw2, and we have seen db2, right? And what we are doing, we are checking the impact of this variable to our loss. What is the impact of that? Okay, now next we will see what is the impact of a1 means the output from layer 1, that is a1. What is the impact of this on loss? Because we require this for z1. So we'll calculate dl upon da1, right? So based on chain rule, we can write like this dl upon dz2 and dz2 upon da1, because z2 that depends on w2 a1 and your b2. So you can write like this dl upon dz2, so that we know that we can write like this dz2. Now dz2 upon da1. So again, what is your dz2? So z2 that is w2 a1 plus b2 b2 upon da1. So it's the same way that we have calculated for dz2 upon dw2, you can find out for dz2 upon da1. So in this case, dz2 as it is. Now this term w2, that is constant, w2 w2 constant, da1 upon da1, that will be 1. So into 1, so it will give you w2 plus derivative of constant, that will be 0. So plus 0, it will give you a w2 only, right? So what we get for da1, dz2 into w2. We have calculated this dz2 and we have w2, right? So we can find out da1. Now on this, how you calculate a1? That is activation on this z1. So let's see, we'll calculate dl upon dz1, right? So based on chain rule, I can write like this, dl upon da1 into da1 upon dz1. Okay, this is your da1, which is dz2 into w2, and this term da1 upon dz1, what is this? This is your, this term, this is your activation or derivative of activation function. And which activation function we are using? We are using sigmoid activation function. So based on the derivative of the sigmoid activation function, we can write this term as a1 into 1 minus a1, right? And there will be, like, da1 is dz2 into dw into w2. Here that will be element wise operation. This is element wise operation, right? So if you have another activation function, so instead of this a1 into 1 minus a1, right? Why I have written like this? Because this is a derivative of sigmoid activation function. In general, you can write like this, g dash means derivative of activation function at layer 1 and on z1. You can write like this, right? So if you are sigmoid, you can write like this, a1 into 1 minus a1. If you have another activation function, based on derivative of that activation function, you can write it. Okay, so this is dl upon dz1. So if you see this da1, so what is da1? Da1 is dz2 into w2, right? So this da1 is dz2 into w2. So here in the calculation, what you observe, if you omit this term like dl upon da1, this time if you don't perform this calculation and if you directly perform dl upon dz1, right, that is fine because you will get this value directly, dz2 into w2, which we have dz2 here and w2, and this just the derivative of activation function. So we have this a1 into 1 minus a1. So no need to find out da1 separately. Okay. So now we have calculated dz1. Next, now on z1. How we'll calculate z1? we'll calculate Z1 based on W1, B1 and X. Now X, that is your training example, so we cannot change that value. Z, X, sorry, X. So we need to find out dW1 and dB1. So your dL upon dW1, which is equivalent to dL upon dZ1 and dZ1 upon dW1, right? And we have just performed the calculation of dZ1, so I can directly write like this dZ1. Now dZ1 upon dW1, so d upon dW1. What is Z1? Z1 is W1 X plus B1, right? So this will be dZ1. Now see the derivative W1 X. So we need to find out with respect to this variable W1. So X is constant. So X dW1 upon dW1, that will be 1 plus this is constant. So again the derivative of constant is 0. So what we'll get? Derivative of this, that is X. So dl upon dW1, that is dW1, that is dZ1 into X, dZ1 into X, right? Similar way, dl upon dB1, because to update this bias B1 we require the gradient of bias as well. So again with the help of chain rule we can write like this dl upon dZ1 dZ1 upon dB1. So it is the first term. First term is dZ1, right? And dZ1 we have calculated here, this thing. dZ1 into dZ1 upon dB1. What is that? So this derivative, but now the variable that we have, that is B1. If you find out that derivative, what you will get as a derivative? You will get 1. dZ1 multiply 1, that will be dZ1 only, right? So for dB1, what we'll get? We'll get dZ1, right? So this way we have calculated the derivative for different terms, right? We have calculated for this dB1, we have calculated for dW1, this dZ1, dA1, dB2, then dA2, dZ2, this dA2, and not with loss. This thing we have calculated 1, 2, 3, 4, 5, 6, 7, and 8 derivatives, right? So if you see the derivative of dl upon dz2, dl upon dz2, this thing. So why we calculate dA2? To find out this thing. But if you see the equation of that dl upon dz2, you can calculate that thing using a2 and y. A2 and y. So we can directly calculate dz2 without this 2. So no need to find out this dA2, right? dz2 you can directly find out like this, a2 minus y. Right? Similar way, this dl upon da1, we can omit this term as well. Why? Because we can directly find out dz1 with the help of dz2, w2 and the derivative of that activation function. Right? So we don't require this da1. So you can directly calculate this. So for this network, how many equations we have? Now we have 6 equations: dz2, dw2, db2, dz1, dw1 and db1. This 6 equation you require, this 6 derivative you require to find out your gradients. Which are the gradients? This dw2, db2, dw1 and db1. With the help of that gradients, you can find out and you can update your weights and biases, right? So here I have put those 6 equations which you require. So you can see what we require. We require this dw2, db2, dw1 and db1, right? To find out dw2, what we require? We require dz2 and we require a1, right? Here I have written capital A, means for M training example. But if you perform on one training example, you can write small a as well, right? So A1 that we have calculated during forward pass, right? So that thing we have, and dz2 that we require. So we will calculate dz2 using this equation is a2 minus y, and this is for M turning example, that is capital A, otherwise small a. So this thing we have calculated dw2. The next is db2. So db2 is dz2 and we have already calculated this dz2, right? So now we have db2 as well. Okay, now we want to calculate dw1. So dw1 that we calculate like this: dz1 into x. This is capital X. Why? For M training example. Small x if you have one training example. So dz1 into x. Now x, that is training example that we have, dz1 that we don't have, so we'll calculate dz1 and we can calculate using this equation, right? So in that you require your w2, your dz2 that we have, and your derivative activation functions derivative, right? So this way you can calculate this dw1 as well. And last, the derivative or gradient of bias which is at layer 1, that is dw1, right? That is dw1. So dw1 db1 that is equivalent to dz1, right? So you can find out that using this equation. Okay, now you have dw2, db2, dw1 and db1. So using this you can update your weights. So how? So let me write this. So W2, W2 that is equivalent to, this is new W. Let me write N, or if you don't write then it is also fine, with old W minus alpha times dW2, right? So this way we update. Why this is minus sign? Because we want to minimize the loss. That's why. And this alpha is your learning rate. way for B2 minus alpha dV2 for W1 minus alpha dW1 for B1 minus alpha dB1. Right, so this way you can update your bias and weights. Now this is for two-layer neural network. If you have n layers, so in that case you can write a for loop, right? So to move on the layers, if you have n layers, so to go to n layers, we need to write loops. We cannot vectorize that thing, right? So in that case, this your 1, 2 that you can write like as a variable I, and then you can use the variables. And this way you can utilize this equation for n layers as well, right? So this is for this second video on backpropagation. In next lecture, we will see the example how actual weights and bias updated using this equation. Thank you.